Hi, and welcome everyone to the webinar, the NTN Sanity check about satellite IoT or non-terrestrial networks. So thank you so much for joining. So I see that the number of people are joining are steadily growing. So we'll start with some general introductions, giving the last people a few minutes to join while we actually kickstart the presentation. So thank you so much for joining, and specifically thank you to all the speakers here. Let me share my screen and go to a few rounds of introductions first. So, Carmen, you want to start?
With pleasure, thank you. Hi everyone, this is Carmen Redondo, Director of Global Marketing for Antennas at Kyocera AVX. I'm originally an antenna engineer, so very involved in the technical topics of this fantastic product.
Thank you. Thanks for joining, Carmen. Maor.
Hi guys, I'm Maor, the CTO and co-founder of Monogoto. Happy to be here and looking forward for our conversation.
Thanks, Maor. Bjorn.
Hello, my name is Björn Rosqvist. I'm a Chief Product Officer at Qoitech. And at Qoitech, we have a solution for analyzing and optimizing power consumption and profiling, emulating, and estimating battery life.
All right, thanks for joining, Bjorn. So my name is Lawrence. I run the IoT Stars community, and I'll be the host of this webinar today. So I'm quite happy with all the experts joining me today because I was fortunate enough to try how this works, but I lack the technical skills. So quite happy with everyone here to allow me to give like a solid presentation. So to start off, the idea for this webinar was initiated because Nordic Semiconductor released the V1.0 of their NTN modem firmware for their new chipset, the NRF9151. And I thought, let's put it to the test because they say that it's production ready, but the use cases, as far as I know, are still lacking, and the big deployments are still lacking. So maybe you heard more about this. I would love to hear your stories. But I thought, let's try it out to see if it's really ready, and if the technology has proven itself. Is it actually viable to use it? Is the cost viable to use it, both in terms of energy consumption, but also link budget, as well as money-wise? So these are the topics that we're going to discuss today. Big shout out to the partners helping me. So Kyocera AVX, Monogoto, TagoIO, Qoitech, and Actinius, who all provided either knowledge or hardware or tools to create the whole end-to-end loop. If there are any questions, you can drop them in the chat and we'll discuss them. We'll address them at the end of this webinar. So also feel free to share any comments, any notes, any experiences you have. So we'd love to hear from you. We have a few points on the agenda. So we'll start with Maor giving us some general explanation about non-terrestrial networks. And then we go to Carmen giving information on the antenna, if there are actually differences in the types of antennas you can use. And then Björn will dive into some yet to be released data on how much energy is actually consumed to send data to satellites out there. And then I'll end this with a demo. So I have my setup right here, and I will start sending data via satellites to my own UDP platform that I've set up with the help of TagoIO. And then we round up with a few Q&As. It has been raining steadily today. There's a short window where it's dry, so hopefully I can do the demo live, but let's see what the weather is going to be in a few minutes, whenever I'm ready, whenever I'm up for the demo. So without further ado, Maor, please enlighten us with non-terrestrial networks.
Hi guys. So the more experts are coming after me. I'm with a networking background, so less about antennas and less about power consumption, but more about how it looks from the top down. And I remember the day that we went to Skylo and saw the first demo, and for technical people like me and my co-founder, this was like magic to look at a small device in a Garmin watch that can communicate with a satellite, LEO satellite, and me with 30 years background of cellular connectivity, and in my early days I used to install 2.4 meter satellite dishes. This was like super magic. So we are very happy to be here. It's a topic that we love. Monogoto is a thing in Japanese, and everything needs connectivity. So we started as a company that sells public connectivity. We added private 4G, private 5G, but I think that satellite is the type of connectivity that can tie all the pieces together. It can give us complete independence. It can give any use case resiliency and a way to ensure that your connectivity will always be there. Maybe not the fastest, maybe not the most the cheapest, but some sort of resiliency and some sort of continuity for different personality of devices that is super important. So public connectivity, everyone knows. Private, everyone knows. Satellite was here all the time, but I think that the big thing and that we all excited about is that we are doing it in the cellular way. So there is a SIM card. The SIM card is authenticating the network. The same SIM card can authenticate to a public network. The same SIM card can, maybe based on business logic, can prefer the satellite over the public or the public over the satellite. And that will completely democratize the industry. Because if in the past satellite was only the vertical markets, maybe army, maybe niche, now satellites can be added to anything. And this is what gets us super excited. We see two movements in satellite. One is terrestrial, LEO, and another one that is GEO. GEO is more exciting, but will come only in later releases. Next slide. Can you go to the next slide, Lawrence? Thank you. To do a revolution, you need an ecosystem. I think Nordic was the last and most important piece in the puzzle. And this is why we are all even more excited. And yes, Nordic introduced the NRF with support of NTN, and Nordic as a dominant player and not a niche player in this market made it super attractive now to companies to add satellite. And ecosystem is super important. So I think that now we got to a situation that most major vendors already have NTN in GA. Sony and Altair with Murata and with Quicktel were the first. Qualcomm have it for a long time, and we see it also more and more in normal phones. And Nordic is adding it, and as a dominant player, this is super exciting for us to see that that it's coming and that Nordic is becoming a player here. Next slide. So at the moment, everyone that talk about satellite, and the satellite that we talk about is NTN, meaning cellular over satellite. We're talking about release 17. There is another release coming soon, and this will be even more exciting because it will support more LEO constellation. It will support more bands that are easier to get landing rights, and it will also support TDD. So the next release is going to be more excited. The nice thing that I see in the market is that most modems are backward compatibility. So you can start satellite today and you don't need to worry about the satellite in the future, the release in the future. And even more than that, with someone like Monogoto, you can get the SIM cards today. And while we are adding more constellations, you can get more coverage. At the moment, Skylo is the biggest and most dominant player in this market. And alongside with Skylo, we have TerreStar in Canada that is a niche player and playing in Canada. We have two LEO constellation that are less attractive at the moment, but will be more attractive in the future because the satellite is much lower, but the constellation is not big enough yet. And the big company that is joining the race is Iridium, that was, I think, the dominant player on the GEO satellite, on the LEO satellite, on the proprietary protocol, and now moving also to NTN. And again, it's super exciting and will help the whole ecosystem to create a democratized connectivity. And if we want to talk about democratized connectivity, I don't know how I am with timing. I hope I'm good, Lawrence. Let's move to the next slide. Revolution, evolution, whatever you want to call it, needs commoditization, needs democratization. You remember the days that compute was expensive and slowly compute is, I don't know, 20 cents per minute, whatever you pay to your AWS. You remember the day that telephony was expensive, and now we are doing a multinational video conference, and we don't really pay for the connectivity or for the communication. The same thing on connectivity, and especially on satellites. The holy grail, I want to pay less than $1 per month. Maybe I will not send as much data as I used to send on terrestrial. Maybe I will need to do some policy that will prevent me to spend too much, because still it's satellite and it's more expensive. But we are seeing the market going to numbers that it's a no-brainer to add to a connected cow or to add to a connected tracker a satellite. It can be pay-as-you-go. You don't use it, you don't pay, so you can use the terrestrial as long as you want. When you need the satellite, you pay for the satellite. It can be subscription. And we are here in Monogoto are advocating that anyone should try it. We are giving free SIM cards, we are giving free connectivity for testing, and we are able to work together with the satellite operators to get to a pricing that will justify adding satellite to any solution that need this extra redundancy. If I didn't cover everything, we'll get questions in the end.
I'm sure there are plenty of questions. At least I get still plenty of questions. Certainly around release 19, when that will actually hit the market and we see devices supporting that. But let's leave those questions for the end. Thanks so much, Maor. And I think these costs, for me, this is already very, very interesting to see, at least adding a number to all of this fuss we've been seeing in the market. But talking about another cost or another constraint is antenna performance. So for me, it's always a bit of magic that a device so small can reach satellite. They're on geostationary orbit, 30,000 kilometers up in the sky. So Carmen, how does this work?
That's why my passion for antennas is like black magic. So just to start, let's start with the specifications for NTN. So there are several. Can go to the next slide. There are several providers right now. You have GEO satellites, you have LEO satellites. In this case, since we are doing the demo with Skylo, so I'm showing just for people to have the reference of what are the specifications for Skylo. So Skylo is using GEO satellites worldwide, and it's using both bands that are available for the L band and the S band. So depending the region, they have a map online. Actually, you can check in the region and you can see what areas are covering, and you can check what bands they're using. Then this is one of the few providers that they offer some certification. So they actually look at the performance of the full performance for NTN, because that's something very important, right? Because connecting, let's say not anyone, but it's easier just to connect. But of course, at the end, you want to have a reliable connection. You want to minimize the power consumption. Otherwise, at the end, it will last very little. And as you said, you are very far away, and it's very important to have a very optimum system. So they are dividing in two types. One of them is the type 1, which is related to high IoT performance and automotive, because there you assume you can have like larger devices. Many times you can have direct side of light light of sight, sorry, and or like in the car, you can direct also to the sky. And then you have the type 2, which is more consumer grade, like wearables or handsets or even trackers, which, you know, sometimes when you cannot control the direction. So in IoT, we are mostly aiming for type 1. And for that, you have the TRP values. Of course, here we have very short time to talk about that, but if someone has questions, we can go deeper after. What is TRP, TIS? So TRP basically is transmitted power. So how much power that they receive the module, and later the antenna is transmitting the whole system. So it's around 20 dBms, which if you look at into the antenna, you means you need to have like a 50% antenna efficiency, let's say. However, the TIS, which is the sensitivity, that's more critical. As we said, the signal from the satellite comes from far away. You know, you are using cellular modules, which already have some sensitivity, you know, defined. Let's say you're not adding extra low noise amplifiers and so on. So this is, let's say, the critical part for NTN systems to get this kind of sensitivity, which should be lower than minus 112 dBm. And then the polarization, you can use either linear or the polarization of the satellite. Depending on the satellite you're using, you can have right heart singular polarization on the left. The most important is, of course, to use the right polarization to match the signal from the satellite. Okay, so if you look at the antenna specifications in the next page, then there is like 3 factors which are important for NTN antennas, you know, comparing to either cellular or Wi-Fi, you know, depending the type of technology you are using, you have some specific parameters which are more important. For NTN, one of them is gain, you know, of course, because you need to close the link budget, right? So you're coming the signal from far away. You want to have enough gain to close this link. Otherwise, you will have more power consumption. And this gain, you know, so if you have, let's say, linear polarized antenna, normally they are omnidirectional. So normally you don't have very high gain, right? And even if you are using a directional antenna that can have higher gain, your satellite might not be facing directly on top of you. So it might have low elevation if it's LEO, or even if you are in a part of the Earth that the satellite maybe is in the North Pole, you're in the South Pole, in the South Hemisphere. And you might have a low elevation. So it's also the gain in those points, which is very important. So this is something to have into consideration. Then the polarization. So as I mentioned, the satellites are sending circular polarized antennas. Of course, you can reach the signal with a linear polarized antenna, but that means that you are missing one of the components of the signal, which in dBs is translated into approximately 3 dBs, which is theoretical. Later, I will show you some results, and actually you can get even better benefit by using or more losses if you use a linear polarized antenna. So it's not always possible to use circular polarization, but when it's possible, it's really recommended because you will earn quite a few dBs in your reception. And then, of course, the bandwidth. So bandwidth, you need to cover, in this case, for Skylo, you need to cover the L and the S band. If you are in certain region, which is only the L band, of course, you can catch with that. But if you want to have a global connectivity, you want to cover both bands. With hybrid antennas, let's say it's easier because it's more bandwidth. But when you want to have circular polarization, it's a bit more difficult to get this bandwidth plus the circular polarization. Okay, so next. So now let's go for the antenna types for NTN. So here is just a little summary, but there you have a QR code where you can download the document, where you can see more in detail and have more time to go into that. But, you know, we were having a lot of questions about, okay, what's the right NTN antenna, NTN, what can we do? So here we are dividing the type of antennas categories. You can have standard hybrid antennas, which are covered in cellular plus NTN. You can have only NTN antennas with circular polarization. You can have chip antennas, which is only for NTN, so it doesn't have the circular polarization, but they are more focused. So let's say you have normally higher efficiency or gain in that way. And of course, custom. Custom, you can do anything, let's say. There's a lot of materials and technologies, so we can really do that for any customization possible. So the first question is your device static static, or you can control the orientation. And this is the way, because if you can control it and you can face your device towards the sky, then you can benefit from circular polarization, as we said before, and then you can get those extra dBs. If not, then we recommend the linear polarized. You know, if you don't control the orientation, imagine you have a tracker with a patch antenna, but then you place your tracker downwards. At the end, it's worse than having a linear polarized antenna, which is omnidirectional. But then after that question, you need to know, is your device hybrid? Does it mean that you want to also cover terrestrial frequencies? You know, sometimes you have devices, because of course, that's the goal of NTN, to complement the terrestrial, but there is some locations, you know, in the, I don't know, in Brazil, South America, in some places where you don't even have terrestrial coverage. So then why you should have also use that? So you can focus only in the NTN and have some more optimized solutions. So there you can see that all the type of solutions you can have. If you have a hybrid solution and you want to benefit from the circular polarization, you can use two antennas, one circular for NTN, and then you have the cellular and you switch between them. If it's not, of course, you use only the circular polarized. If it's linear polarized, you can have an antenna covering everything, but you can also benefit from having a chip antenna, which can improve the performance of the NTN. And then, of course, if it's only NTN and linear polarized, you can also have just a small chip antenna on your device. And then the next page, we can see a bit more in detail. So this is just a little part, but there's more information on the document. When you're looking in hybrid antennas which cover everything, are basically the traditional cellular antennas. The S-band is already covered because they are some of the LTE bands. You just need to extend a little bit to cover the L-band, which is most of the cases, depending on the antenna design, but most of the cases is possible. So in our data sheets, we show the configuration that you need to be able to cover all the bands. And as I mentioned before, these are linear polarized, is for devices which are moving. And then, of course, you need to go through all the considerations when you integrate antennas, which is the PCB size, placement, case studies, and use case, and so on. So this is another topic. And then for the circular polarized, so here there's some different solutions, but we have designed a very innovative solution, which is the LDS cap antenna that Lawrence will be testing later. And we started, with the L and the S band solutions, which are focusing only on those bands, and they have circular polarization. So you will see later the benefit of that. This antenna is actually hollow below, so you can put the module below. And then we are looking at the end of the year to have the external version. So even if it rains in the future, Lawrence, you will be able to do your, your testing as well with your antenna with the semi-connector. And then we are having, that I will mention at the end, something in the roadmap will come later this year, which is going to cover the L plus S band. And we start already sampling some few of them right now. So in the next page, so just we have a lot of data. We have been with our partners doing a lot of testing, among them, some of them with Skylo, with Nordic. And here's one example just to show you what's happening in real life when you're testing those antennas, and to show what I'm mentioning about the circular polarization. So RSIP means stands for reference signal receive power. This is one of the parameters that you check when you are taking this kind of measurements to see the power level of the signal you receive from the satellite. And you can see that when you're using the cap antenna, which is the only antenna circular polarized in this test, you can get much higher RSIP. So it's around minus, 16 or so, 17 dBm. And then you will get, is 4 dBs better than you use an off-board antenna with an SMA, and more than 6 dB, I think it's almost 9 dBs compared to an embedded antenna. So even if all of them will connect, or you have other type of external antennas will just connect, in reality, you will see much better performance, but better quality of connection when you use the circular polarization. And now I think I would like to show you some real products. So we have been working for a while, and we're glad to say that we already have products in the market that have been Skylo certified, or they're in progress, almost there. And here we are showing some examples. Oh, I saw that we are missing some titles there, but I didn't catch. So the first one is a hybrid tracker. So it's a tracker reference design from one of our customers that they are using all cellular bands plus NTN. And it's using one of our standard antennas, the 1,047,095, and it has been certified by Skylo. So it's very easy to replicate and to see if you want to make a tracker device, you can do something similar, and they're open to share the design. Then the second one is only NTN device, and it's a multi-sensor, and it's using our cap antenna. So as you mentioned, sometimes it looks a bit large, but if you can put the module below and you benefit from the space in that way, so electronics are below the antenna. And this solution right now is with the L bands, and they are right now working on the L+S, so I think it will be the first product having the both bands on with circular polarization. And the last one is a custom design. So as I mentioned, we can do any type of technology and manufacturing technology, FPC, LDS. In this case, we are designing an FPC antenna, which is covering all the GNSS LTE bands, GNSS, and also L+S band to certify with the Skylo. And it's a cattle management tracker. As you can see, it's quite small for in the ear of the cow. So of course, none of our standard antennas will be suitable. So it has been really designed together with the whole system, you know, with the solar panel and everything to make it work and be certified. And the last slide will be where I was saying what's next. So our goal is to be able to have the antenna, you know, that covers all L+S, so we can have different constellations, go to the LEO, to the GEO, that to be able to have, you know, seamless transition between terrestrial and satellite, and of course, dual polarization. So this is something that we are working. This antenna is not only going to be L+S, but it's also going to have left-hand or right-hand polarization. That means that it will automatically connect to the right polarization depending on the satellite constellation you are using. So our goal, of course, is to make this design that can be affordable for IoT in the IoT industry, that can be compact, easy to integrate, because I think this is very key in the industry, in the IoT market, to this kind of profiles. Yeah, hopefully it was useful information.
All right. Thank you so much, Carmen. This is super interesting. Definitely the examples that you also showed, that this is actually real and happening, and there are real devices out there that are being used as we speak. And I think the beauty is that you don't have to understand all of this to make use of satellite communication. As I did, I just started using your antenna and the devices at hand, and then that's enough for me to at least start building NTN-based use cases. So thanks so much, Carmen. I'm sure there are more questions about this, which we're going to address later on. So Bjorn, up to you about other type of costs, which is the cost of energy. What does it cost to send data?
Yes, exactly. Thank you for that. So yes, please. So what I did, I took our equipment, very portable, so it's very easy to go out in the garden. Luckily, this was a sunny day, not like today, Lawrence, right? So I was in my garden doing this measurement, and as you can see, I had two identical setups. So you can, next slide, please. And so the setup similar, same hardware, same software. Actually, the only difference between these two setups were that one was communicating through the terrestrial and one was communicating through NTN. So next, please. Okay, and this is where I will be going live, sharing my screen. So let's go for that. Yes, so I hope you see my screen of the recording. So when it's communicating, it's doing some different things. So it starts with NTN communication. It needs to have GNSS fix. So what it do first is that it needs to get this GNSS fix. So I have been doing this measurement. So let's just have a look here. So the cost in doing this, it only needs to be done once if you're stationary. So the cost here is roughly 1.4 milliwatt hours to get this fixed. So this is not needed when you use for the normal terrestrial measurement. And the second thing that then happens is that it will then go into registering phase. So it will register to the network. So I have both the NTN registration here and the terrestrial here. And as you can see, there is a little bit difference between these two, of course. For the terrestrial, roughly 265 microwatt hours. And as you can see, the current consumption is peaks of 60-ish milliamp here. And when talking to the satellite, of course, this is far away. So if this was whispering, this is more like shouting to the satellite. So of course, the current consumption goes up. As you can see, I now have higher peaks of more than 300 milliamp. And the energy cost for this registering phase is 2.95 milliwatt hours. And then it's time to communicate, to send the data. Also here, you will see the same difference in consumption. Talking here is roughly 200 microwatt hours. And with the satellite being far away, of course, it's cost more. 2.45, again, higher current consumption for speaking with the satellite. Okay, so then, and the message that was being sent, it was the same length of message. It was a text string of 28 characters. And then the question then comes, okay, this is current consumption figures, but what does this mean for a battery? So I'm gonna give you an example here of doing a battery life estimate of these two different use cases. So let's start by entering some data here. From the data sheet of the Nordic chipset, it doesn't like to go below 3 volt. Below that, it will brown out. Also, the sleep current, when I was doing the measurement, you can see I have something in the neighbor of 600 microamp. This is due to the application that I'm using because I'm communicating through UART commands. So this is not the real sleep current. So I have been examining this before, and the cost of having this UART is roughly 600 microamps. So actually my sleep current is very low. It's down to 3 microamp roughly. And then I have the activity of sending the data. So let's start by doing an estimate for the terrestrial part. I then add this activity, and the communication was once per hour. So I keep this. Just selecting a battery. For this, I'm just going to select alkaline battery, and I need to have a little bit higher voltage than 1 single cell, so add them in series here. And let's then just run this estimate. So the tool now do a battery life estimate based on this real measured data and the real battery data. So 1,860 days, that's 5 years, something like that. And then let's go back to do the comparison with then NTN. So let's do a change here. Take the data from the NTN device instead, and then do the same estimation. And not surprisingly, screaming takes more energy, so 141 days. But this is not really a fair comparison, since if you're communicating through the terrestrial, of course you need less power, and you only use NTN when you need to, when there is no other communication possibilities. So this is a little bit unfair. So when you are in the NTN, maybe you collect more data, you transmit more with longer times in between. So just to make a comparison, if I then send, maybe I transmit twice per day, I collect the data and then I do the transmission. Maybe the cow, I just need to send the data that the cow health is okay, or something like that. So with sending twice per day, I get, this is like for a little bit more than 4 years, 4.4 years, something like that. So this is a walkthrough of the current consumption of these two use cases. And let me then stop sharing and get back to the slide, please. If I can get back, thank you. Okay, so this is just a summary slide with the different measurement I did and with the estimated lifetime. Of course, we also have published an article yesterday. You have the QR code there on this slide as well, if you would like to read more about how we did this and the result. And last slide, please. Yes, and this is, you need to measure, only trust the real measurements. So measure every damn day. Thank you.
Okay, thank you so much, Bjorn. Fascinating to see these big differences. But indeed, as you say, it's an unfair comparison to compare terrestrial networks with non-terrestrial networks because they're so different. Yes. And yeah, like it's so cheap to use terrestrial networks. I think pricing from Monogoto is, I don't know, then you don't talk about kilobytes, you talk about megabytes, which is probably a cent per megabyte. So it's an unfair comparison because your whole device behavior is completely different. But it's also good to see that with those constraints, it's still possible, if you change the behavior with sending less data, that you can still receive multiple years of battery life with your device. Okay, this is the part where I am up, but unfortunately I see that it started drizzling outside, so I will share what I've done, and I actually did a recording yesterday of how I put everything together. So I'll be sharing that recording, and I'll promise you, if you don't think that it's sufficient, then I will give you a private live demo at another time when it's not raining. So the setup. So I have the, I will share them here as well. So I have the Actinius Icarus board. So they integrated the NRF9151 chipset, and they actually built a development kit around it, but you can also just order that system on module itself, allowing you to easily integrate it. I used a passive GPS antenna. You can either use a passive or an active one. That depends on the configuration of the module itself. And as we already discussed, or as Carmen already discussed, I use this L-band NTN optimized antenna. So with that setup, I send data directly to Skylo, and Skylo has Monogoto has a native integration with Skylo, as long as you use the Monogoto SIM in a way that directly forwarded to the Monogoto core network, and then it ends up eventually at the endpoint you define it yourself, which in my case is TagoIO. So that was my setup. So the ones that I just showed you, this is the core hardware pieces. This is more or less what my setup looked like. And for comparison, I also used, let's say, a normal or terrestrial terrestrial narrowband IoT antenna, and that has the same results. I didn't track the exact power consumption or time, how long it took to connect to a satellite, but at least I did get the same results, which was quite promising. And for the setup, I use the open source asset tracker template. So there's a GitHub branch from Nordic, NTN use case. So I used this. I only had to slightly modify the endpoint that it ends up at the TagoIO platform. And I had to modify the data format, because Tago defines a so-called Tago TIP format, which is a lightweight, human-readable IoT telemetry protocol. And then the data I send looks something like this. And of course, you have to add your security token. You add your device name, and there you add then you send the actual data. So this is one of the recent messages I sent, which is temperature followed by the location, and you can add some metadata as well. So all of this in total is 76 bytes. So I checked the Monogoto portal, and they give you in very much detail how much data is actually sent, including all the overhead, which comes down to 104 bytes. If you then do the quick calculation, then it rounds off to 150 bytes, as in the payment round off, which is roughly 4.5 cents per message. But what you can directly see, you can minimize this payload. You can reduce or get rid of the metadata. You don't have to write out temp, but you can do some smart things at the back end to actually reduce the payload format.
You can also remove the device ID if you use Monogoto VPN and you take the IP address as a device ID.
Nice, that's an interesting note. So there are tips and tricks to actually reduce the payload, reducing the amount of cost per message. But at least this gives you a bit of some information, some guidelines. And this is what I mentioned, it's a pretty cool feature at Monogoto. So you can see all the events directly when a device connects to a satellite. You can see the event logs when that connection happened, but also if any data is sent. And they have this feature, NetFlow, where you can see what type of data to what IP destination was sent. And this also shows the exact number of bytes that Monogoto routes. Fun thing, I went on a holiday trip last week to France, and I took my NTN kit along, and I've been basically tracking my trip. So this was quite fun to see. So you can see exactly where I've been. I went through Belgium, France, I went to Paris, and then I spent some time just below Paris before getting back home. So this is all based on the TagoIO platform. And then I would like a few minutes to share the demo that I recorded yesterday. So there we go.
In April 2026, Nordic Semiconductor released the V1 of their NTN modem firmware for their NRF9151 chipset. Well, the V1 tech means that it's ready for production. But is it really, and at what cost? Well, I'm gonna find out. I find myself in the middle of nowhere with no cellular connection whatsoever. And I gathered all the tools necessary to start sending IoT data over satellites, including the Actinius Icarus board with the NRF9151 chipset. In addition, I have a GPS antenna and I have the Kyocera NTN antenna optimized for the satellite L-band. In addition, I have the Monogoto SIM with a native integration to Skylo's network, and I have access to TagoIO's UDP server. Why UDP? Well, non-terrestrial networks only support UDP communication. So let's put it all together and start building an NTN tracking application. Let's get started. I got my board, I'm connecting the GPS antenna, as well as the Kyocera NTN antenna. Once connected, I connect my device to my laptop. First thing is updating the modem firmware. So I'm heading over to Nordic's website, the NRF9151. I go to downloads and I download the NTN firmware. Once downloaded, I go to the NRF Connect for desktop and I open the programmer. I select my board, dragging the latest firmware onto these boards. Once done, I select write, and this may take a couple of seconds before the new modem firmware is flashed onto the board. Completed. So I found the asset tracker template developed by Nordic, and it has the branch end-to-end use case. And I'm using this as the application to run on my device, and I only had to slightly modify the template to point to the right endpoint, which is TagoIO's UDP platform. Okay, and doing a quick reset of the device, opening up my serial monitor, and I start monitoring the device's behavior. At the same time, I'm moving the device to a spot with... Hey, you want to have a look? There we go, the device with the antenna. Okay, still scanning for networks. No satellite in fix just yet. In the meantime, I do have a valid GNSS fix, so the latitude, the longitude has been defined. The next step is for the device to connect to a satellite somewhere out there. Any updates already? Yes. Okay. I see that the device is connected, and what I see here, 76 bytes. Temperature, location is being sent to the TagoIO platform. In the meantime, I'm refreshing the Monogoto platform, and I can see that the device is connected to Skylo's network, which is pretty cool. It's authenticated, it's connected, some data has been sent. Okay. Well, let's go to the TagoIO platform. Click refresh. It can take a couple of seconds before data arrives, and there we can see something. Okay, here is the location. There's some metadata, which is the name of the device. 47 sounds quite a lot, but it's in the full sun right now, so that's probably right. Once created a small dashboard, it looks something like this, where the data is plotted. I added a table, and once more data comes in, I actually see the graph of the temperature data. It's easy, it's simple, and I have my full data visualization up and running. Awesome. So the device sent data via Skylo's satellite network. It moved through Monogoto's core network and ended up in the TagoIO UDP platform. All the hardware and all the tools that are used are easily accessible, and you can get started with all of this in no time. So I invite you to try this out yourself and let me know how it's going. Thank you so much for watching, and good luck on your NGN journey. My name is Lawrence, and thank you for watching.
Okay, this far the demo. So you have to believe that this actually happened yesterday. And it was fun to play around with. And indeed, as I mentioned at the end, all the tools that I used are freely or are accessible. You can purchase them. If you give Maor or me a message, then we can probably send you a free SIM package to get started with. And all of the other products are just ready to purchase. And the TagoIO platform is also free up to a certain number of devices. So all the tools are available, and then that leads to the final question, which probably you have to decide for yourself. Is it all worth it, and does it actually work for your type of business case? Well, at least for me, it worked pretty easily out of the box. I had quite a happy experience, quite a happy flow with building this. But indeed, you have to decide for yourself, does it fit the pricing, which is, of course, significantly higher than terrestrial networks? Does it fit your use case with the amount of data packages you send? So that's all questions you have to decide for yourself. Yeah, and last thing is, like I mentioned before, you don't need all of this knowledge and skills yourself, as long as you know who to team up with. So at least there are 3 great partners here who can help you with all of the technicalities, so you can only work on your use case. Yeah, before we go to questions, big round of applause for our speakers who helped me giving some body to this presentation. So thank you so much, Carmen, Bjorn, and Maor. And
thank you, Lawrence.
And yeah, in the meantime, I saw lots of questions coming in, and I think the most or quite?
I have one comment, Lawrence, when you're looking at the question, because I wrote it, but I think it didn't appear my comment. So Eric was saying, talking about the rain, how much affects. And I wanted to say that we had even partners testing with the snow over the antenna. So it could be, I think the biggest challenge to have equipment which is water protected, of course. And that's the biggest challenge. But, the DBs you are losing, they are critical for the communication, but not impossible. You can still connect.
Okay, that's interesting. And so one question, not sure if you already answered that, about the 300 microamps peak. Like, do normal batteries support that, or you need to look at specific batteries that actually can support that peak?
No.
The peak current.
Yeah, so it's no specific battery needed. A lot of battery can handle these 300 milliamp. So of course, there is more a question: what are you using it for? Together with solar panels and so on, then it's typically rechargeable batteries, and they typically have low internal resistance and can handle peak currents. If you have a primary battery, non-rechargeable batteries, you need to look into this to make sure that you can get the most out of the battery energy, because it's during these peaks that the device will reset.
Yeah, understood. And so I have one question myself, because at least the test that I did and the test that you did, Bjorn, we didn't use the NTN optimized antenna you discussed, Carmen. So we don't have the real data here, but can one of you guide or has some information on how much that affects battery life?
Well, I'm not antenna expert. So I hope, Carmen, you have the...
You need to do the whole thing, right? The whole calculation. But just theoretical, as I was saying, you can estimate like 3 dB more. So you are receiving 3 dB more. So if you receive 3 dB more, which in practice could be more, then you need to make your battery calculation to see how much. I'm not an expert in battery life, so I think it needs to be a combination.
No, but I think that will be a difference that you will see.
Yeah, and I'm not an expert here, but I can imagine if you use a better antenna, then the connection with the satellite will be established faster, and that kind of that duration, if you manage to shorten that will have a significant effect. Maor, you talked about release 17, which is basically what all of the modem vendors are using today. So when do you think we'll see release 19 coming to market?
Will take time. That's not the answer you want to hear. I would start with 17. So I think Nordic and Iridium are doing some testing, and a few others. You can see press releases, but it will take like 2-3 years at least.
Okay. So you say don't wait for it. Start with whatever you have today.
Yeah.
So Rajit, the devices I used here, at least this is an evaluation kit that I used. But Actinius, they basically design specifically the system on modules. So as far as I know, they integrate the nRF9151, and they basically put it on a board, allowing you to easily integrate it into your own design. And the Kyocera antenna, I don't know if this one is ready for production, but at least similar ones like these can be integrated into your product right away, as far as I understood.
Yeah, they're available online. So the L-band, the S-band, antennas, evaluation boards, and then hopefully after summer we can have the L+S. It's almost done.
Great. Then I have one more question for you, Maor. So we saw some examples that Carmen shared about real devices. Do you see anything on your network already? Are there companies going for real production use cases, or they're mostly tinkering around?
No, we see more than 300-400 different use cases that our companies develop. Most of it's POC and prototyping and playing with it. I think more than 10 already starting to scale. I think agriculture, connected cars, asset tracking is the immediate use cases. In agriculture, we are talking about livestock monitoring. So connected cows. You remember if Nokia used to do connecting people? I think we are now connecting cows. Yeah, I think that eventually most of the outdoor use cases can just add it for resiliency, insurance, or just as a backup connectivity.
Yeah, nice. That's good. It's good to have that knowledge. So I see a question from Dan, which is quite a practical thing. Maybe Maor, you feel comfortable responding here. So what about OTA updates? Is that feasible on satellites, and then specifically on LEO satellites, because these satellites fly by so quickly? Do they even have enough time to push an update to a device?
So depend what, we are doing a lot of over-the-air update to prioritize satellite or to prioritize cellular. That's easy. I don't think that with today network you can do real over-the-air update over geo, because as you guys show in the demonstration, we are talking about it's take like 5 seconds to send a few 50 bytes. So I don't know, maybe if you do auto update that is super tiny, maybe it's worthwhile doing it. But SGP32, like changing profiles, stuff like that, I would definitely look into. I will definitely think that this is super visible to do it with NTN. Maybe with geo satellite that are more capable, you have like a window of 10 minutes. So if the satellite is right above you on this 10 minutes until the constellation will be big, you can do a more proper software upgrade.
Yeah, gotcha.
I saw another question on NIDD, sending over signaling instead of UDP, and yes, we are working to support that also together with Skylo.
Great. So Miguel, is the product ready to operate reliable in remote areas using only cellular NTN? Well, hopefully the demo showed that that is the case.
Guys, all these Garmin devices, the new Garmin devices, are using Skylo network. It's not public information, but if you will, will break the device, you will find out that it's used Skylo and a SIM card. So yes, it's already production ready.
Yeah, nice. Okay, so we really moved beyond the prototyping phase. It's really out there, and it's there reliable. Okay. I might have missed 1 or 2 questions, but hopefully I captured most of them. We'll follow up. I'll send you the resources, so at least the link that Carmen shared and the long read about Bjorn, your whole analysis. Hopefully Maor will provide me a link so you can request your own NTN SIM card. And
just reach out. You can get SIM cards and even modules if it's hard for you to find them.
Amazing. Great. So Bjorn,
and even
after all of these,
we have partnership with Kyocera. Even antennas we will send you.
Even antennas. Amazing. Nice. Bjorn, after all of this research, are you still positive about the real-world implementation of NTN?
Yeah, absolutely.
Okay, amazing. Thank you so much. I'll thank you again to all the partners involved. Apart from these online sessions, we're also having in-person networking events. So the next one is happening in November. Will be after the summer, but in Electronica. So keep an eye on your inbox. Keep an eye on iotstars.com for the next in-person event. That said, thank you so much for listening. Again, thanks for all the speakers, and I hope to see you again soon at one of these online or in-person events.
Thank you.
Good luck on your NTN journey.